Now, this is an example of decision tree, which is a statistical model in machine learning. The given problem is that the ABC Corporation, a corporate trader, has acquired a shoe company and is contemplating the future of one of its major plants located in Marikina. Now, there are three alternative decisions which are being considered. First is to expand the plant and produce lightweight, durable shoes for possible sales to the department store, a market with little foreign competition. For number two decision, maintain the status quo at the plant, continuing production of shoes that are subject to heavy foreign competition. Or the last one is sell the plant now. Now, if the one of the first two alternatives is chosen, the plant will be sold at the end of the year. The amount of profit that could be earned by selling the plant in a year depends on foreign market conditions, including the status of a trade embargo bill in Congress. And we have a given here that we have to develop a decision tree for this decision situation with expected values at the probability node. So we can use this formula that we can use that finding the expected values, just simply the mean, which is the mu, is also equal to the sum of the product of the outcomes times its corresponding probability. So from the given table, we have to find the expected value for these three decisions. So we have it here that the first step is we can construct the decision tree, which is these three nodes B, C, D are of course, the three options for the decision. We have to expand the plant, maintaining the status quo in the plant, or selling the plant now. And then these values are based on the given table, wherein for expanding the plant, there is a good conditions and the amount is 30 million, and for the bad conditions is 20 million. For maintaining the status quo, the given value is 50 million for the good condition, and for the bad is negative 7.5 million. And for the selling the plant, we have 15 million for the good conditions and 15 million for the bad conditions. So the corresponding probability here is 0.75 for the good conditions, and of course the 0.25 for the corresponding bad conditions. So finding the expected value, so we have to compute the expected value using the formula that the sum of the outcomes times its probability. For node B, which is expanding the plant based from the given, the good is 30 million, the good conditions is 30 million multiplying with the probability as 0.75, and the bad condition amount is 20 million multiplied by its corresponding probability. Then the expected value for expanding the plant is 27.5 million. For node C, it refers to maintaining the status quo decision. So using the given value for the 50 million for good condition multiplied by the good condition probability of 0.75 minus the bad condition value, which is 7.5 million, to be multiplied by its corresponding probability. So the value of the expected value for maintaining the status quo is 35,625,000. And for the node C, which is selling the plant, the good condition is 15 million to be multiplied by its corresponding good probability, and for the bad condition, 15 million to be multiplied by its probability for the bad condition, which is 0.25. Then the expected value for selling the plant is 15 million. And then the next step is you can now consider the value for the expected value for the expanding the plant, maintaining the status quo, and selling the plant. And then based from this, you can have now a decision which you can consider the maintaining status quo in the plant because it has the highest expected value. So you have here that you have to select the highest solution among the circle nodes and make the decision. So here the decision is to maintain the status quo because the expected payoff of 35,625,000 is derived for the given criterion as finding the expected value. So we have a concern here that when only one decision is to be made, the decision tree will always shield the same decision and expected payoff as the expected value criterion. Yon.